Okay, so I think you can hear me now. So you are watching the I think video series of questions, probable questions, which we expect in this year XC paper for fluid mechanics. That is what we are doing. As I told you earlier, also fluid mechanics is there for mechanical engineering paper. It is there for civil engineering paper and for XC paper. Now, fluid mechanics in XC paper is little different from that in mechanical and civil engineering paper. And why you should write with XC? Because that gives you advantage to get good GATE score and land up in IITs and get into good job. That is the purpose. So today I'm going to take a topic which is related to fluid mechanics, and that is metacentric height. I'm sure you people are aware what is metacentric height, and usi ka I am going to take some question. So metacenter and metacentric height, there can be a question, a numerical, based upon this small concept of metacentric height. So hota kya metacenter, that question MSQ can come from metacenter, and what is metacentric height, from these two concepts it can come. Okay, number one, metacenter is a concept which is related to floating bodies. Before I discuss with you what is metacenter, let me tell you there are some floating bodies. Let us say this body is a floating body. How do you find what is the center of buoyancy and what is the centroid of a body? This is how it is obtained. This is how it is found. Now you should know what is the significance of these 2 points also. That significance should also be known. So let me give you this diagram here. This I'm giving you one floating body here, and for this floating body I'm giving you center of buoyancy and the centroid of this particular body. See this carefully. This center of mass or center of gravity is a term. G is center of mass of the body. Center of mass, if mass is uniformly distributed, it is called centroid. So this does not depend whether body is in liquid or body is not in liquid. It does not depend upon that. So how do you find it? It is a geometric center. If mass is uniformly distributed, it is a geometric center. Now entire weight of the body is concentrated at this G point and it is vertically downward. Now there is another point which is called center of buoyancy. What is the significance of that? Significance of that is entire buoyancy force acts upward at this particular point. So B is center of buoyancy. Center of buoyancy. What is the significance of center of buoyancy? The significance of center of buoyancy is entire buoyancy force acts on that. Now, how do you calculate the weight of the body? Weight of the body is volume of the body multiplied by density of the body. Density of the body into volume is its mass into G gives you weight of the body. How do you find out the buoyancy force is equal to weight of liquid which you have displaced? Weight of liquid displaced is the buoyancy force, that is FB. Now if the body is floating, buoyancy force is equal to weight. The buoyancy force will be equal to weight if the body is floating. Now if the body is floating and you disturb that body from its mean position, if you disturb this body from its mean position, then what happens is this body starts oscillating. This body will start oscillating if you disturb it from its mean position. Now let us say this is the original line of symmetry of this body. This is the line of symmetry of the body. You understand? The body must be having some axis of symmetry. Like human being has this axis of symmetry. So this is the axis of symmetry of the body. Axis of symmetry of this body. Axis of symmetry of the body is this. Now tell me which of these 2 points will shift? G and B may say which point is going to shift? Answer is G point is not going to shift. G point is going to remain same. But you know, this B point, center of buoyancy, it is actually, center of buoyancy is nothing but it is the centroid of the volume displaced. Can you find one thing here? Can you see this? How did I find the center of buoyancy? Center of buoyancy is the centroid of the displaced water, displaced liquid. It is the geometric center of displaced fluid. What is the center of mass? Normally it is the centroid of the entire body. G is the centroid of entire body and B is the centroid of displaced fluid. Now when the shape of displaced fluid changes, then there is a very high probability that this B point will also change. This B point will shift from here to here. Earlier this B point was, let us say, at the axis of symmetry. As you can see in this diagram, B point was on the axis of symmetry, but now this B point has changed to new location. Why? Because this entire body has, now this shape has changed. Now the displaced fluid is more on this side. Now the two forces still will act. That is, the buoyancy force still will act. And let me now tell you, the buoyancy force, which is the vertical force, will still act, and the line of action of this buoyancy force will meet the original line of axis or axis of symmetry of this body, and that point is called metacenter. Now the point which I wanted to discuss was metacenter. So what is metacenter? This is that point at which the line of action of the buoyancy force is a vertical line of action of the buoyancy force will cut the axis of symmetry of the body. That point is called metacenter. But that is not the only definition of metacenter. There is another definition of the metacenter, that is, this is that point at which the body will start oscillating if it is displaced from its mean position. If you displace the body from mean position, it starts vibrating or oscillating. That point about which it oscillates is called metacenter. But there is a catch in this. That point at which body will start oscillating if it is displaced from its mean position by small angle, not large angle, small angle. Because if you increase the angle, it is possible that maybe body will topple and it will not vibrate, it will not oscillate. So that point about which it starts oscillating is defining its metacenter, and metacenter is always related to the basically floating bodies. That is number one. Now see one more thing. If I displace this body from its mean position, now the weight is still acting downward and buoyancy force is acting upward. And I told you one thing, buoyancy force is equal to the weight of the body in all these three cases. In all these three cases, weight will be equal to buoyancy force. Now I have a small question to ask you. Will this volume, submerged volume, and this submerged volume, will these two volumes be same or different? Answer is both these volumes will remain same. Why? What is the buoyancy force? Equal to the weight of liquid displaced. So can I say the mass if FB remains same? Because weight does not change. If weight does not change, FB also does not change. If FB does not change, mass of liquid does not change. If mass of the liquid displaced does not change, volume of liquid displaced does not change, and hence this volume and this volume are going to remain same. That is first point. Second point, when you displace this body, you displaced it through clockwise couple. Now these two forces which are equal and opposite forces, you see this carefully, FB and W are equal and opposite forces, and these two produce the counterclockwise couple. So one is disturbing torque, another is stabilizing torque. So if the metacenter is above G point, then this body will remain in equilibrium. It will again come back. Even if you displace it from its mean position by small value, it is again going to come back and it is going to make the body stable. That is the stable. So what is the condition of stability of floating body? Condition of stability of floating body is M point should be above G, yeah, G point should be below M point, and that is a principle which is used to basically make the design the shape. सो सी में जो शिप बनती है, उसकी जो शेप बनती है, दैट इज ऑन द बेसिस ऑफ दिस कंसेप्ट that entire G should be below and the displaced, displaced volume will keep on increasing. So entire weight is at the bottom, G point is at the bottom, and M should be as high as possible. Numerical will come from metacentric height. Now, what is metacentric height? That is what I'm going to discuss with you now. Metacenter height, and then we go for some kind of numericals. Metacentric height होता क्या है? मेटासेंट्रिक हाइट किसको बोलते हैं? एम जी डिस्टेंस को मेटासेंट्रिक हाइट बोलते हैं. सो एम से जी तक का डिस्टेंस इज कॉल्ड मेटासेंट्रिक हाइट. I just now gave you a diagram, small diagram I gave you, and then we discuss what is how it is to be calculated. Let me make this diagram once again. I am giving you larger diagram. Understand? This is the axis of symmetry. Let us say this point is G point. It can be anywhere. Let us say this is G point, and let us say now this is B point. For simplicity of the diagram, I am making this, for simplicity of the diagram, I am giving you this. Let's say this is a buoyancy force, and let us say this is M point. So what is the metacenter? Metacenter is that point at which line of action of the buoyancy force will cut the original line of action. So M से G तक का distance is called metacentric height. It is called metacentric height. How do you calculate? Let us say this point was, this is B dash, original B was this, right? So can I say M से G तक का distance, can I say B से M तक का distance, B to M minus B से G तक का distance? Can I write like this? See this carefully. This distance is called metacentric height. This is called metacentric height, and in the numerical we have to calculate this metacentric height. Now this is equal to M to G, sorry, B to M minus BG. Now there is a way to calculate BM. And how do you calculate BM? That is I over V dash. I over V dash. What is I? I is the moment of inertia of plan section at the interface with respect to axis about which body oscillates and passing through centroid of this section. So try to understand what is this I. I told you this is I over V dash. What is I? Moment of inertia of the plan section of interface with respect to axis about which the body will oscillate and it is passing through centroid of the section. I'll explain you what is the meaning of that. And what is V dash? V dash is volume submerged. This is the volume which is submerged. That we can calculate how much is the volume submerged. That remains same. So volume submerged remains same. Now let me tell you what is the meaning of this. Let us say this particular part, this is the body, this is the shape of the body. Let us say this is the shape of the body, and let us say this is the liquid in which it is basically now submerged. Or let's try to take it inclined. It is similar to, let me give you this diagram. Let us say this is the shape and this is the body which is now submerged. This is the free surface of the liquid, and that is the shape of the body which is submerged. You will get similar to this numerical only. You will get this numerical only. Okay, now let's say this side is B, this side is D. Now let me tell you, if the body is going to oscillate, this body is going to oscillate, it is going to oscillate about this point. So visualize this. The body, if you topple this body, it is going to oscillate like this. If you tilt it by small angle, it is going to oscillate about this axis. And you need to basically calculate the moment of inertia of this section about the centroid of this plan. Plan is the top view, but you are not to take the top view here. You have to take the top view at the interface, water interface. But because it is rectangular shape, whether you take top view or you take the view at the interface, that is going to remain same. Hence, can you tell me what is the I for this? Moment of inertia of this is now dB cube by 12. dB cube by 12. This is D, this is B, dB cube by 12. That is the moment of inertia. Now this is the moment of inertia, and what is V dash? This is the submerged volume. Now let us say this is H. Let us say this part is H. Can you tell me what is the submerged volume then? Submerged volume V dash will be equal to BD into H. I am very sure you understood this. So this is BD is the cross section area and H, that is BDH. So you get this particular V dash also. And how to find different distance BG, that you know, if the shape is given to you, B and G can be calculated. That is very easily to be done. This can be easily calculated and you can find it out. That won't be a trouble for you. Now what differences he can put in the question? He will not give rectangular, he will give you triangular shape. Triangular shape, but at the intersection, at the water interface, that triangular, if you see the plan view, it will not look like triangular, it will look like rectangular, because triangular is this section may be triangular, but if you go at the back side, it will have a width also, and that top section will look like rectangular only. That is where he can make some kind of difference in the analysis, but most of the cases I think he will give you this case only. Now let me frame the question on the basis of this what we did. Let me frame some question. What kind of question can be framed? So let me give you some questions now. पहला क्वेश्चन मैं तुम्हें देता हूं MSQ. MSQ क्वेश्चन देता हूं. So which of the following defines metacenter? Defines metacenter. I'll give you theory question and then I'll give you numerical. Metacenter को कौन define करता है? A, point about which floating body starts oscillating if is displaced from mean position. That is number one. That is the definition of metacenter. Number two is point at which line of action of buoyancy force meets original line of, or let us say axis of symmetry. That is second statement. Third statement is point of stability of floating bodies. D is centroid of submerged part of body. So this can be multiple statement question. This way multiple statement question can be framed like this. So answer for that is A and B. Both these are correct. Both of these are correct. Metacenter से क्वेश्चन आएगा इस बार. So this is metacenter, multiple statement question. These two are correct. These two are correct. So understand these two meaning. Okay, am I audible to all of you now? Okay. This is the metacenter. Now let's go for next question. Let me frame next question. This is the next question. Which of the following defines stability of floating body? Choice A, center of gravity. Choice B, center of buoyancy. Choice C, metacenter. Choice D, all of the above. What answer will you go for that? Which of the following defines stability of floating body? Let's take it MSQ. Now answer, what answer will you give? Which of the following defines the stability of floating body? You know, the question can be ticklish. You think you know the things, you think that you know the idea. Questions can be very close. How do you define? Which point defines the stability of the floating body? Answer is center of gravity, metacenter. G should be lower than M. ये है स्टेबिलिटी का कंडीशन. This is the condition of stability. You know, it can be close. Like you think you know the concept. Only metacenter will define. No. Only metacenter cannot define. Only metacenter cannot define. Let me frame another question for you. Shape of a ship is so designed that it, choice A, keeps metacenter far higher than center of gravity. Choice B, keeps metacenter near center of gravity. C, keeps submerged volume of water very high. D, minimizes the drag force of water. Yes. Now give me the answer. For this. Shape of ship is so defined that it keeps what? क्या करेगा ये? मेटा सेंटर को ऊपर करेगा, नीचे करेगा? आंसर लगाओ. MSQ. Take it MSQ. Multiple statement questions. Take it as MSQ. What do you think? MSQ. Yes, I'm waiting for your answer. Metacenter far higher than center of gravity. Whenever you come across two statements which look like contradictory, एक अलग statement दूसरा अलग statement contradictory है, only one can be correct, not both. So I want to keep metacenter as higher as the center of gravity, because I want the metacentric height to be more. More metacentric height means more stability. Let me tell you that this metacentric height, mg, this defines the stability. Let me write somewhere here. Keep metacentric height as much as possible to keep body stable. If the metacentric height is very high, that means if m is far more than g, body will always be stable. So metacentric height should be kept very high, body will be very stable, and that is the reason now keep the metacentric height as high as possible. Yes, the shape is so designed that I should have maximum submerged volume. You know, the shape suddenly increases, the size suddenly increases, the displaced volume, because the more the volume of the liquid displaced, more will be the buoyancy force. इसलिए ऐसा shape ship का बनता है. I want to keep like that, as much liquid as displaced as possible. So I need to have that. And you know, you third is, yes, I want to minimize the drag force also. आगे से कट करेगा वो, जब शिप आगे जाएगी तो ड्रैग फोर्स लगेगा, तो शिप इस तरीके से जाएगा लिक्विड के अंदर से कि उसको वो कट करता हुआ जाए वाटर को. सो ड्रैग फोर्स आल्सो इज टू बी मिनिमाइज्ड. सबमर्ज्ड वॉल्यूम, मेरे पास ज्यादा वॉल्यूम डिस्प्लेस्ड हो, कीप सबमर्ज्ड वॉल्यूम ऑफ वाटर वेरी हाई. Submerged volume, I think this is a statement I need to recorrect it. Keep displaced volume, not submerged. Displaced will be better word. वो submerged body का submerged volume जो है उसका displaced volume होता है. So I need to keep displaced volume of water very high. जब ship जाएगा तो water displaced is high, because floating के लिए that gives you buoyancy force. So these three things are kept in mind when you are designing a ship. That is how it goes. That is how we have to plan it. Okay, let me now frame this question, and then we go for numerical. Which of the following is correct related to floating bodies? Choice A, specific weight of body is more than that of liquid. Specific weight of body is more than that of liquid. Is this correct statement? So if there is a floating body, specific weight of body is more than that of liquid or not? Second choice of this, weight of body is balanced by buoyancy force. See, if body is tilted, then buoyancy force is changed. D, if body is tilted, then volume displaced is changed. Okay, read these four statements. Tell me which one do you think are correct? Is or are correct? Specific weight of the body is more than that of liquid. You know, if the body is floating in the liquid, density of the body is rho, density of the liquid is, let's say, rho w, then density of the body is less than density of the liquid, then only it is floating. And similarly, specific weight is nothing but specific gravity, that is also less. Specific weight of the body is less than that of, specific weight is weight per unit volume, that is rho into g. Basically we are talking about the density here. So density of the body rho g is specific weight. Specific weight is nothing but weight per unit volume, which is nothing but mg per unit volume, which is nothing but rho into g. G remains same, so I am comparing the density. Density of the body is less than density of liquid, then only it is floating. And density and specific gravity, how they are related? Specific gravity is nothing but density over density of water. So density of the body is less than density of the liquid, then only it is floating. First is incorrect. Weight of the body is balanced by buoyancy force, that is correct. Floating में ये होता है. Body is tilted, buoyancy force is changed, no. Because still, even if it is tilted, the buoyancy force and weight will be balanced. And buoyancy force is nothing but volume displaced, weight of the volume displaced, weight of the liquid of volume displaced, weight of the liquid displaced, sorry. So that volume of liquid displaced also does not get changed. Only answer correct in this is B. That is the only answer which is correct. That is how we need to see this. Let me give you a question now on the metacentric height, and this is what is expected. So let me give you question numerical. A rectangular body, you can write this question with me. A rectangular body of width b, of particular width which is given to us b, submerged depth, and we are also given the submerged depth. Up to what depth it is submerged? Submerged depth of capital H has its center of gravity, has its center of gravity, has its center of gravity at water surface, at water interface. So write this statement in your copy, keep writing the question. So there is a rectangular body of width b, it is submerged up to depth h and has its center of gravity at the interface. Find the metacentric height, that is a question. Find metacentric height, metacentric height in terms of b divided by capital H, and show that for stable equilibrium, for the stable equilibrium, b over h should be greater than equal to root of 6. That is a question. First I want you to write the question. Write the question. There is a rectangular shaped body with width is given, and also it is given up to what depth it is submerged. You know, these kind of questions you can answer only if you visualize what kind of diagram it will be there. Let me give you the diagram here. This is the body, and let us say up to this depth capital H, it is submerged in the liquid. Now width is given to us as b, that is the meaning of width. Length is not given to us. We are not bothered about what is the length of the body. Let us say that we are not bothered. So let's say this length is L and this width is b. Now this is the diagram which is given to us. That is how the body is. Now we know that how we have to identify this, how we have to find it out. Let's try to see this. Now, one more information is given that G is at this point. That is the information you have to think. G is at this point. Okay. Now, let us say this is B. Any idea what is B? Yes, sir. B is nothing but it is the centroid of the submerged part. Okay. Can you tell me how far is this? This is h by 2 and the rest is also h by 2. Okay. So can you tell me now how much is the B से G तक का distance? Can you tell me what is B to G? This total is h. This is h by 2. So h minus h by 2 is h by 2. Just check it out whether everybody understood or not. We know that center of buoyancy is the centroid of the submerged part. ये h दे रखा है तो यहां से नीचे से बॉटम से b तक का डिस्टेंस होगा h by 2 and g is given at the interface. So b to g distance I know this is the distance b to g. How to find out metacentric height? Metacentric height is nothing but distance m to g. M to g is metacenter height. Metacentric height is this, which is nothing but I over v dash minus bg. Can you tell me what is I? I is the moment of inertia of this body about this axis. About this axis. Any idea what is this I? This I is LB cube by 12. LB cube by 12. L is not given. Let's see. LB cube by 12. Okay, done. What is V dash? Can you tell me how much is the volume submerged? Yes, capital H B into L. Understood it? Capital H into B into L. And that is the reason L will get cancelled out. The moment you put it, what you get? LB cube by 12 over H B L. L will get cancelled out. Minus BG is H by 2. Okay. 1 power. So this comes out to be B square over 12. B square over 12H minus H by 2. Minus H by 2. If I am not wrong, this is the value we are going to get. B square by 12H minus H by 2. Now for stable equilibrium, so for stable equilibrium now, what we condition is required, metacentric height in terms of B by H we have to calculate, that is what we have calculated. For stable equilibrium, now for stable equilibrium, you know whether the equilibrium is stable or not, if BH, this mg, metacentric height should be greater than equal to 0. That is a condition. That is a condition for stable equilibrium. M should always be above G, means mg should be positive. This is a condition for stable equilibrium. Make it greater than, so B square by 12H should be greater than equal to H by 2. You know what will happen is, this is what we wanted to prove. So H square, so B by H whole square should be greater than equal to 6, or that then gives you this answer, stable equilibrium. And you know what question can be framed from this particular concept? He can give you the real values and ask you find out whether the floating body is stable or not. If mg comes out to be positive, if mg comes out to be positive, let us say, if this value mg comes out to be positive, then it is a stable equilibrium. If it does not come out to be positive, it is unstable equilibrium. He will give you this case only, and he will ask you find out whether this body is stable or not. Let me see, let me say in this particular case now. In this particular case, let us say he gives you B as let us say 3. He gives you B as 3 meter, H as 1 meter. B as 3 meter, H as 1 meter. Tell me, is this stable or not? Let me frame this question now. This is the two situations he has given you. Rectangular body. Now, this is H, this is B. Understood? Now, in this case, case number 1, case number 1, case number 2, B and H. Now go back. This is a rectangular body, everything is same. B by h should be greater than b by h whole square should be greater than 6. I give you b as 3, h as 1. B as 3, h as 1. B as 2, h is 1. Same rectangular body. And my question is, in which of the following situations you get stable or unstable equilibrium? See this question. So find out whether this is stable equilibrium or not. The moment you take B3 and H1, what you get is 3 by 1 whole square, 9 is greater than equal to 6. B by H whole square, stable. For stable equilibrium, of this floating body, what we should have is B over H whole square should be greater than equal to 6. That is a condition. Now, in this case, B by H whole square is coming out to be 9. So it is stable. In this particular case, B by H whole square is coming out to be 4. It is unstable. This is how you decide whether some floating body is stable or unstable. That is something which is important for us to know. It defines the stability of the body. Let me frame one more question here for you. From the metacentric concept only. A cube of side A floats with one of its axis vertical in a liquid of specific gravity let us say SL. If the specific gravity of cube material is SC, find the value of SL over SC for limiting condition of stability of body. And he has given you answer choices also. A 4.7, B 2.7, C 1.3, D 3.1. Take it as MSQ. Believe me, this is a really good question. I want you to attempt it, think it of and attempt it. Think it of and attempt it, how you will do it. What do you think will be the answer for that? So I'm telling you, this is a metacentric height questions we are doing, and this is the expected question in your XC paper of fluid mechanics, which you can write. If you're a mechanical engineer, you can take second option subject as XC. Okay, should I give you the diagram now? As I told you, without diagram we will not approach. This is the cube. You know the meaning of cube? All the sides are equal. And let us say it is floating in liquid with height h. This is a free surface of liquid a, and you can give me even I in this case now. Can you tell me what is I now? I is b dq by 12, a raised to power 4 by 12, a into a cube by 12, that is a raised to power 4 by 12. That is the meaning of I, a raised to power 4 by 12. Okay, can you tell me what is a v dash now? How much is this? V dash is nothing but a square into h, cross section into h, submerged volume, right? Okay, now what is the weight and what is the buoyancy force? Floating body mein this is what is happening. If the body is floating, don't you think weight of the body is equal to the buoyancy force? Okay, what is the weight of the body? Let us say specific gravity of the body is s cube. Specific gravity of the body into density of water gives me density of the cube. Density of the cube is nothing but specific gravity of the cube into density of the water. Okay, density into entire volume of the body gives me mass of the cube into acceleration due to gravity, weight of the cube. Weight of the cube is nothing but density of the cube, volume of the cube into g. I hope you understood it. Buoyancy force कैसे निकालते हैं? इसका weight. इसका weight निकालने के लिए specific gravity of the liquid into density of the water into volume displaced. वो कितना है? A square into h is the volume of the liquid displaced into g. सही है. Rho w will get cancel out, g will get cancel out, and what we will calculate from here is, let us say s l over s, l over sc. Why? Because he wants us to calculate it. इसको हम बाद में एक नाम दे देंगे. Let's call it as some value x. S l over x c is x, that is the value, and it comes out to be a over h. A over h, because second power will get cancelled out and h. So x I want to find, which is a over h. Done. That is a over h. That is what I want to find out. Now, what is b to g height? Can you tell me what is b to g height? Okay. Now g is, you know, g point is this, b point is this. अगर मैं यहां से यहां तक का डिस्टेंस ले लूं, दिस इज h by 2. अगर मैं यहां से यहां का डिस्टेंस ले लूं, दिस इज a by 2. See carefully. g is at a by 2 and b is at h by 2. इसका हाफ, शेडेड रीजन का हाफ, शेडेड रीजन इज h, उसका हाफ इज b पॉइंट फ्रॉम द बॉटम. टोटल साइड का हाफ इज g पॉइंट. सो b to g is nothing but a by 2 minus h by 2. Everybody understood? A by 2 minus h by 2. A by 2 minus h by 2. But I don't want to write in a and h. Let's put it in terms of x. So can I write h is equal to a over x? And if I do that, bg for me is a by 2 minus h is nothing but a by x. A by 2x. So can I take a by 2 common? Can I take now a by 2 common? A by 2 common if I take, it is 1 minus 1 by x. 1 minus 1 by x. That is bg. That comes out to be bg. Now what is bm? What is bm? This is nothing but I over v dash. I कितना निकाला था? A raised to power 4 by 12. And what is b dash? A square into h. A square into h. Let's cancel out something. Comes out to be a square over 12h. But h कितना था? h अभी तो निकाला था हमने. h is nothing but a over x. a over x. पुट करते हैं इसको. एक और x कैंसिल हो जाएगा. ax over 12. ax over 12. So what is mg now? mg is equal to bm minus bg, which is nothing but ax over 12 minus, what is bg? BG is a by 2 into 1 minus 1 by x. a by 2 को कॉमन ले लेते हैं, x by 6 minus 1 plus 1 by x. Is this correct? This is mg. But limiting condition is what? What is limiting condition of stability? Limiting condition of stability. Limiting condition of stability is that mg should be greater than equal to 0. Okay, if that is the case, x by 6 minus 1 plus 1 by x greater than equal to 0. 6x से मल्टीप्लाई करते हैं, x स्क्वायर minus 6x plus 6 greater than equal to 0. Just check it out whether I am correct. X square minus 6x plus 6 greater than equal to 0. The moment you solve it, you get two values of x. Number 1, 4.7. Number 2, 1.3. And these are the two values. MSQ. These are the two values. The moment you solve this quadratic equation, you get these two values. You know, GATE exam is neither easy nor difficult. It is not difficult if you do practice. If you have practice of writing a lot of questions, a lot of equations, if you do that, it is not difficult. It is not easy either if you do not do practice. It is not easy either. So these things you need to keep in your mind. So that is what the GATE exam is. This question will tell you that, okay, there's a lot of concepts. I mean, simple concepts, but you need to solve it. So let me summarize the things from where we started and then we ended up the class. I started class with metacentric height, which is a very, very important concept. Metacenter hota kya hai? Then I defined that there is a term called metacenter. How do you obtain it? Then before that, I defined what is center of mass, which is called center of gravity also, center of buoyancy. How do you find it? And what is the condition of stability? M should be above G, yet GM height should be positive. Then we defined what is metacentric height is mg, and for stability this should be greater than metacentric height as much as possible. For stability, what should we have? Mg should be greater than equal to 0. That is the condition for stability. So anything you are designing, mg should be greater than equal to 0. That is what we said. And after that, I gave you theory questions. I gave you some theory questions. What is the metacenter? Actually, this is the definition of the metacenter. That is what I told you. These are the definition of metacenter. After that, I told you that, okay, floating bodies, stability of the floating bodies, how it is to be defined and how it is defined. And metacenter height, mg, is metacentric height. If stability of the floating body is asked, mg should be greater than equal to 0. That is, the metacentric height should be greater than equal to 0. Then some more questions. How do you design the ship? And what is the correct statement related to floating bodies? Some theory questions. Right? And stable equilibrium. What is the condition for stable equilibrium? That is what we did. And then we solved two numericals, very simple numericals. This question, this numerical, and this numerical. So this we solved, this numerical we solved. That is how it went, right? So it was a simple question. So I think these 4 or 5 questions, I'm very sure if I give you these 5 questions, 6 questions without the concepts, you will make some mistakes. So revise it well. Let me see what your point is. Okay. Question class for GATE. Yes. Marathon revision live for all subjects. Ruchin sir is the very good mentor. Ruchin sir is the fantastic teacher of civil engineering. Ask him, he may take it. He can continue. In fact, he is going to take many classes live. And Vishal sir is going to take for mechanical engineering. Other mentors will also jump for mechanical engineering. So many classes are going to come now in the month of November, December, and January. 3 months, lot of classes will be there, don't you worry. So we'll have a lot of classes. Just keep enjoying these classes, keep revising, and XC paper, don't forget. If you want to get into IIT system with very good departments, very good placement, just focus on XC 2-3 सब्जेक्ट, और उससे तुम्हारा निटी बॉम्बे भी मिलेगा और उससे IIT भी मिल जाएगा. बट गो विद योर पीडीएफ फॉर XC. थैंक यू.